and send her the YouTube link. So we are recording. Wednesday. Is it Wednesday?
Yeah.
Oh my gosh. Wednesday, September 2nd.
Wow.
At WSSB, third period geometry. Geometry.
Oh.
All right. So we're going to talk for a little bit. We're going to think for a little bit. We're not going to open up a book just yet.
Oh, shoot.
About this whole geometry business. So yesterday I talked to you about you're going to learn how to be geometry attorneys.
Yep.
You're going to learn how to go to the geometry court with Judge JJ, and you're going to learn how to represent whatever client you've brought into the court and convince me, Judge JJ, that the client is most likely guilty of something. Probably guilty of being a point, or guilty of being
a triangle,
or guilty of being an acute angle, or guilty of having one angle equal to another angle. Okay? You're going to learn how to do that. And in math, that's called a proof.
Yep.
You learn how to prove that something is happening, and you learn how to write it up. And you write it up in a systematic way, in a logical way. Well, how you kind of go about that and how we kind of scaffold that is we got to start giving ourselves credit that you've kind of done this stuff. Yeah. When you think about things, you start going, oh, I see what's going on here. Yeah. And you come up with some sort of conclusion around something because you've experienced it. That's so, for example, if you always walk outside on a cloudy, blustery day, it seems to rain on you every time. Almost always, right? Always. Your experience. You walk outside, it's your experience, right? Let's say, or I'll just say for me. So I always walk outside and it's cloudy and it's blustery and I get rained on somehow. So then I come up with a conclusion. I say, if it's cloudy and it's blustery, then it's going to rain on me. Okay? So I've just made a statement. I've noticed that every time it's cloudy and blustery, it rains on me. So I've made a statement about that. I've said, if it's cloudy and blustery, then it's going to rain on me.
Yeah.
The if it's cloudy or blustery is the hypothesis of my statement. Have you heard that before?
Yep.
Hypothesis?
That's a big scientific word.
Oh, big scientific word, right? It's the if. Right?
I know what it means.
And then it's going to rain on me is the, right?
Yep.
Okay. But how I made that statement was I did some reasoning. I did some what's called inductive reasoning. I went, So another thing might be if I notice that when I do my homework, when I'm taking a class and I always do my homework, I always get a really good grade on my quizzes and my tests. And when I don't do my homework, then sometimes I don't get good grades on my quizzes and tests. Sometimes I get lucky, but oftentimes I don't get a good grade on a test. So I keep doing that. I keep testing that out. I do my homework, I take a quiz, I get a good grade. I skip my homework because I wanted to go to the movies tonight, and I take my quiz the next day and I don't get a good grade. So I'm noticing something about that, right? I'm doing that and I'm noticing a pattern. Noticing this, if I do my homework, I get a good grade. If I don't do my homework, I don't get a good grade, right?
I understand what you mean.
Do you understand what I mean? So I'm making a statement. So my statement would be, if I do my homework, then I will get a good grade on my quizzes or my tests. Does that make sense?
Yeah.
So I've noticed a pattern about something that's happening, and then I've made a statement about that pattern that hopefully is true. Okay?
But what if it's not true? Then you have a problem.
Then we have a problem there. Yes, we've had a circumstance where, oh my gosh, I did my homework and I still biffed the test, right? So then I might have to use some qualifiers. I could say, if I do my homework, I almost always, right, get a good grade. We could use a qualifier, couldn't we? All right? So what we're doing there is we're noticing something about a pattern of things.
Yep.
And then we're making it's reasoning that we're doing, and we're making a statement about that with an if-then kind of thing, all right? So we could do that with numbers. Why don't you, either on your Braille notes or on your Brailler or on a whiteboard, do you want to use Brailler or whiteboard or Braille note?
I got a Braille there.
Okay. You want to use a whiteboard? Okay.
Yeah.
I'll use my Braille note.
You want to use your Braille note?
Yeah.
Okay. It's just going to be a series of numbers, so Braille notes are okay. So I'm going to write down the numbers. We should all write these down together.
Hold on.
33.
Wait. I'm not even close to being ready.
Wait. You want to eraser? I'll run next door and grab some erasers, and Peggy's going to read off the numbers that I wrote on my whiteboard to you guys.
Okay, so 33, 39, and 45.
Got it.
Alright. Whiteboard.
Does anybody else need me to repeat that?
33, 39, and 45.
Yeah.
Great.
Alright. So, you're a mathematician, you encounter these numbers, 33, 39, 45. And you look at them, you go, huh, nice numbers. But,
I noticed something else.
ooh, Peggy notices something.
I know who's the next one.
Ooh, so Erica's saying it is a multiple or factors of 3. 3 would go into 33 11 times. 3 would go into 39 13 times. 3 would go into 45 15 times.
Oh, well.
What else do you notice about this series of numbers? 33, 39, 45.
There's 6 between each of them.
Yeah, goes up by 6 each time, right?
Oh yeah.
33 plus
yeah.
6
I thought it was
is
3, but it was.
is 39.
Yeah.
39 plus 6 is
45.
45. Oh, okay. Well, considering we only have these 3 numbers to work with, could we make a reasonable conclusion about these numbers, that they're going up by 6? Could we say the next 3 numbers in the series based upon
51, 57, 63.
51,
Yeah.
57, 63. Oops, I wrote 66.
Well, yeah, because
Yeah.
they all go up.
Exactly, they go up by 6.
Yeah.
So if I have this sequence of numbers, 33, 39, 45, and they're going up by 6 each time, then I know that the next 3 numbers would be 51, 57, and 63.
Yeah.
Because I've noticed a pattern, right? I've noticed a pattern about my sequence of numbers. Okay, this is called a common difference between numbers. Okay, all right, all right. So we're looking for a pattern. Just like when I was looking for the pattern, if I do my homework, I most likely get good grades on my quizzes and my tests. If I go outside and it's cloudy and blustery, it most likely will rain.
Yeah.
If I look at this series of numbers, I notice, oh, it's going up by plus 6, then the next 3 numbers, 51, 57, 63.
Yeah.
So we're turning on our brains and thinking about looking for patterns. So let's try the next one. How about 13, 8, 3. 13, 8, 3. Erica's yelling out it's going down by
So
5.
we can go up by 5.
Yeah, there you
3,
go.
8, 13.
Well, you don't want to change the pattern.
Okay.
-2.
Yeah, not in this
Negative
case.
5.
So it's always going to go down by 5. So if 3 is 3 minus 5 is what?
Negative 2.
Negative 2. Negative 2.
And then negative 7.
Negative 7.
Yep.
Negative 7 to. What's the next one? Down by 5 from negative 7? Negative 12.
Negative 12, yep.
Yeah.
Yep.
Going down by 5. Or if we subtract 5, what's another way of saying we're subtracting 5?
Taking away 5.
Take away 5. That's another way to say it. What's another way of saying? What? Decreasing by 5.
Oh, there we go. Yeah.
Okay. Another way of saying
Taking away?
taking away. I heard that one. Subtracting by
you
5.
did.
What about? Can we use adding in this case?
Yeah.
What are we adding?
-5.
Yeah.
Oh, there we go. Yeah. That counts.
Adding negative 5. That's another way, right?
I was like, wait a minute, what? But then I just realized I was like, oh,
Excellent.
okay.
Right. So we either say it's going down by 5, we're subtracting 5, we're decreasing by 5, we're taking away 5, or we're adding negative 5, right?
Yeah, totally.
Okay. Yeah. So common difference in that. All right. Let's try another one. How about some decimals? How about 1.25 or 1 and 25 hundredths, right? 1.45 and 1.65.
It's going up by 20.
Wait,
Going
hold on
up
a
by
minute. Hold on.
20
1.25,
or
1 point.
what do you want to say? By 0.20 or 0.2.
1.20.
Yeah.
1.25, 1.45,
1.25, 1.45,
and 1.65.
1.65. Yeah.
Let me have 1.85.
1.85.
Mhm.
Okay. What would be the next one? Was that Trinity?
No, I don't think I'm right.
Oh, so the consensus is it's going up by 0.2 or 0.20, 20 cents. So 1.65 would become 1.85.
Yeah,
What
there
was
you
the next one? 2.05, and then what's $2.05 plus 20 cents? 2.25. Yeah. Think money sometimes. It helps your
Yep.
brain do it a little faster.
True.
All right, good. Okay, let's get a little. Okay, I'm warning you. This one may be a little trickier.
Okay.
Ready? 1, 3, 9. 1, 3, 9.
Okay, so it's going up by 3 and then 6 and then 9 and then 12.
I know 1 to 3 and 3 to 9.
Would the next one be AP?
Nope.
Yeah, that's right.
Oh, I see what you're doing.
So look for the pattern. Don't always assume it's adding something.
Ooh, we could subtract.
You could subtract. Don't always assume it's adding or subtracting.
Multiply?
You could multiply.
Oh,
You
there
might.
you go.
I don't know. Think about is there a How did you get from 1 to 3 and
You
3 to
1
9?
times 3.
Oh my gosh. So
There you go,
multiply
yeah.
What
3
did you
times
multiply by?
1 to get to 3 and then 3 to get to 9.
So you're multiplying by what each time?
The number.
3.
3.
Yeah, there you go.
Ah.
That completely makes sense.
Get it?
I get
Yeah,
it.
1 times 3 is
That's what I was
3.
thinking.
3 times 9 is?
No, 3 times 3 is 9.
3 times 3 is 9.
Nine.
Thanks, Peggy. And then now, so we're assuming now our reasoning that it's multiplying by 3. So what would be the next term? 27, because 9 times 3 is 27. Now we got to do 27 times 3.
91.
Oops, almost.
81.
81, good. And then 81 times 3.
243.
243.
I'm
Nice
using
job.
a calculator.
Yeah, you're using the calculator. That's all right. Use your resources. I didn't say you couldn't.
That's helpful.
Okay? You're in advanced mathematics now. You can use your calculators.
It can be extremely helpful.
It can. It makes you faster. All right. So now you're these budding Euclidean geometrists and mathematicians and attorneys of geometry and having to notice patterns and
yeah.
make some sort of inductive reasoning around it and estimate or guess on what's going to happen next. So you notice, oh, I can add something as a pattern. I could subtract or add a negative as a pattern. I
Multiply.
could multiply as a pattern, right?
Or divide if
so
you wanted to.
you might come across something that's dividing. Let's try another one.
Okay.
These are fun.
You like these?
Yeah.
I love these.
All
I
right.
can do it all day.
32, 16, 8.
Oh,
4,
going,
2, 1.
yeah. Wait, no, because it's going down by 8.
32, 16, 8. Let's see.
Divide by 2.
Oh.
It would be 4.
Oh, yeah, it is dividing by 2. Okay, yeah. Okay, I see it.
Oh, there you
Oh. Divide by 2. 32 divided by 2 is 16. 16
Oh,
divided
there
by
you
2
go.
is 8. 8 divided
Yeah.
by 2, 4. 4 divided by 2,
2,
2
There you
divided
go.
by 2,
1.
1 divided by 2, 0.5 or 1/2. Good?
Yeah.
Yeah, nice. I mean, I went a fourth term with you. Notice we could
Mhm.
go into infinity dividing by 2, right? Okay. So it's a division by 2. What's another way to say dividing by 2?
Splitting in half.
Splitting it
Yeah.
in half.
Yeah.
All right, splitting in half. All right, what's another way? How is division related to multiplication?
It's kind of in the reverse order.
It's
That's how
reverse,
I think
it's
of
an
it.
inverse. So if I'm dividing by 2, what would I actually be multiplying by?
1/2.
0.5 or 1/2,
Yeah.
right, Erica? Mm-hmm.
Yeah.
Yep. So we could also say 1/2 of 32 is 16, right? 1/2 of 16 is 8. 1/2 of 8 is 4. 1/2 of
Right.
2. So we could be multiplying by 1/2 or dividing by 2, right?
Right.
Okay. All right. Ready
Like-
for another pattern?
Okay.
Now it's going to get interesting. I'm warning
Okay.
you again. 1, 3, 7, 13,
Ooh.
21.
I think you're adding up by numbers. So you add 2,
Mm.
then add 3, then
Wait,
add
1,
plus
3,
4.
okay.
Oh. then
1,
add
3,
6,
7, 13,
4,
21.
5.
I can tell it's going up.
No.
That's for sure. Let's see. Whoa.
It's going up for sure. You're putting your brains on, thinking about, it's going up for sure. Have the yelled out, went up by 2. I heard somebody say, I heard Trinity down here going, it went up by 4, it went up by 6.
And we're by 8.
Oh, Peggy's saying it's going up by 8. Oh.
31.
Ooh, what's it going to go up by on the next one?
10.
10.
Oh.
So 21 and 10 is 31. Then what's it going to go up by? If it went up by 10, it's going to go up by 12. So 31 plus 12. Then what's it going to go up by? 14. So then we're going to get 43 plus 14. So the next three numbers are 31, 43, 14. Or excuse me, 57. So what happened there? Your pattern, you noticed, 2, 4, 6, 8. What happened? Was there a pattern within a pattern? Oh, yeah. You noticed, my common difference or the common change, it also had a sequence, didn't it?
Yep.
What's the pattern of the pattern? What's the pattern of the 2, 4, 6, 8? What's its common difference? 2,
yeah.
isn't it?
Mm-hmm.
So you had to figure out that had a plus 2 to it to figure out the next three terms of that, right? 10, 12, 14, and then add those to your original, right? So those are examples of more complex, right, patterns. It's not only just about, it always goes up by 2, or it always goes down by 5, or it always goes up by 20 cents, or it always it's multiplied by 3, or it always is divided by 2. Well, sure. But then sometimes it has two things going on, right? Like, it's going up, and it's going up by a positive 2 on on what it's going up by, right? So interesting. Okay, so don't always just stop at one pattern, right? One like, oh, I see what's going on. All right. Okay, ready? Test it out here. Those brains on. We got 10.
Okay.
12. 15. 19.
So that's going up by 2, 3,
Hold on. 12, 15.
5.
Wait.
10, 12, 15, 19.
Okay, 10. 12. 15 and 19.
10, 12,
I know what the next three numbers are.
19.
Me too. I kind of like those kind of things.
I
I
do
always
too.
when I read it.
So you notice what?
That it's going up by a number each time, so it starts at 2.
Starts at 2.
Add the number.
Add a number and go up by 3.
Yeah.
So have we got
Bless you.
a pattern of our pattern,
Love to do those.
right?
Yeah, we got the
a
same
nested
situation.
One. Yeah. So what's your
Yeah.
next 3 terms?
Make your brain work.
Sometimes.
24, 30, 37, right? Because from 19 we got to go up by 5, right?
Yeah.
So 24. From 24 we got to go up by 6. And then we get 30.
Yeah, okay.
See that? And then from 30 we got to go up by 7. We get 37. And then from 37, what are we going to go up by?
8.
8.
No. Oh, yeah.
45. You got it, Justin. Right on.
Yeah.
Pretty cool. Okay.
Yeah,
So
that's
they
right.
started out at 2 and then went up by 1s from there. Okay, here's another one.
Yeah, that.
1, 2, 6,
I think she does. She has an email in her iPad.
and 24.
Oh, wow.
1, 2, 6, and 24.
Oh, I hear your brain thinking,
3
Tabitha.
times 4 is 12, and then 24, right? No, it's 6 and then 24.
1 times 2 times 3 times 4.
Wait a minute. I hope I wrote it right. 1, 2, 6.
1, 2, 6, 24.
Oh, why did I write 14? Whoops.
All right.
I was like, wait, that doesn't seem right. Okay.
So
I
you're
hear Tabitha's
seeing
brain
multiplication.
Oh yeah, times 4.
So I heard Tabitha say 1 times 2 is 2.
Times 3 is 6.
2 times 3 is 6.
Yeah.
6 times 4 is 24.
Oh,
Oh, what is 24 going to have to multiply by?
5. So that'd be
5. 24 times 5.
It's 125.
30.
Oh no, that's not right.
I heard.
What is 5 20s? 100. What's 4 times 5? 20. 120. Okay.
Yep.
Then what are you going to multiply 120 by? 6. Whew. What's
Wow.
12 times 6?
12 times 6.
72. 720. Then what are we going to multiply 720 by? 7.
Wow.
Maybe we want to cheat, huh?
Yeah.
We don't say cheat. We'll use our resources,
Whoa,
which is our calculator, right?
calculator. Is that Orion thing?
Yep.
5040.
5040.
I remember Husai showed me that
That
thing.
is correct. So we
Typical
I
had.
didn't use a calculator.
So how
Wow.
did you do? Nice, Peggy.
That's impressive.
What happened there if you were to go to court and say, I've got this sequence of numbers, 1, 2, 6, 24, and I absolutely know that the next 3 numbers are 120, 720, 5040. How would you prove that? How would you say to the judge the reason why you know 120, 720,
Because
5040?
1 times 2 is 2, and 2 is 6.
Mm-hmm.
But times 2 times 3 times 4.
Okay.
It just keeps going up.
All right. So you would say, I'm noticing that my original series of numbers is multiplying.
Mhm.
Multiplying by a pattern that's increasing by 1, right? It starts at 2,
Yep.
and then I'm increasing by 1 to 3, by 1 to times 4, by 1 to times 5, by 1 to times 6, right?
Yeah, exactly.
And so therefore I'm able to tell you 24 times 5 is 120, then there's 120 times 6, I got to go up 1, is 720, and 720 times 7. So judge, what would be the next one? The judge should say, oh, I need to multiply 5,040 times 8. And you would say, yes. Okay? All right? So think about how you would explain, right?
Yeah.
You would describe what's going on here. All right, you ready?
Okay.
Phew.
We should do a math.
Want to do a math lib?
What's that mean?
Where I give, we have a story problem with, and we
Or
ask
Mad
for,
Libs, yeah.
it's a math lib. We ask for. All right, so we'll do a math lib, but I ask for numbers. So Trinity, give us a number to start with. 12. All right. And thinking about the relationship of 12 and another number. Somebody give me another number. 70. 72. Okay. All right. So I was like, how do we get from 12 to 72? All right. Okay. So thinking about the relationship of 12 to 72 in a sequence, and that's all you have to go on. Well, let's do one more set of numbers. What would you want to be the next number?
72.
72.
6. 432.
How about 432?
Okay.
All right, so 12, 72, and 432.
This would be multiplied by 6.
Multiplied by 6. Yeah,
Yeah,
multiples
there you go.
of 6 is your pattern, isn't it?
Yep.
So your next 3 digits, 432 times 6.
Yep.
Right? That number times
And then that
6.
times-
And
yeah.
that number times 6.
Yep.
Whew, that was crazy. We started out with a crazy math lib. How about I give us a little bit simpler one? How about 10, 7, 4,
Oh.
1.
It's going down for sure.
10, 7, 4,
10. Hold on. 10,
7,
7.
4.
You're right, it is going
1.
down by 3.
You want a talking one or a big one or?
It is going down, you're right, though.
Yeah, it's going down by
3.
3. All right. So what are the next 3 digits?
You go to negative.
Negative land. Yeah. Negative what? Negative 2. Negative 5. Negative 8. Good job. Yeah.
That makes sense.
All right. How about 3, 6, 12, 24?
Oh.
3, 6, 12, 24.
Goes up by 3. Oh, no, it doubles up.
Doubles, yeah. Times 2 are doubles, yeah. 3, 6, 12, 24. So what's the next one? 48.
Yep.
Next one? 96. Next one? 180. 90 and 90 would be 180, and 6 and 6, 12, 192? 192, good.
Interesting.
All right. Okay. How about 1, 3, 5, 7? Goes up by 2. And then what are these numbers? 1, 3, 5, 7, 9, 11, 13.
Odd.
Odd. Yeah, odd, right? We start out odd number 1 and add 2. We're always going to have the next odd, right?
Yeah.
Okay. All right. How about, this is a weird looking one. How about 7, 8, 11, 16? 7, 8, 11, 16.
Oh, it's going 1, 3, 5, 7, 9. It goes up by odd numbers, but
Let's go 23.
So the next number is 23. Why is it 23, Attorney Humphreys?
Because so far it's gone up by 135, so it has to be 7
Okay.
next.
All right.
Oh, I get it. Yeah.
Okay.
32.
Okay. And then 11. 43. Yeah, 23, 32, 43. So you notice from 7 to 8 it went up by 1. From 8 to 3 it went up by 3.
Mm-hmm.
From 11 to 16 it went up by 5.
Yeah.
You're noticing, 1, 3, 5. It's going up by odd numbers, right? Every 2. So 7, 9, 11 would be the next 3 that it would have to go up by. So you'd add 7 to 16, you get 23. You'd add 9 to 23 to get 32.
Yep.
And you'd add 11 to 32 to get 43. That's kind of weird looking one, isn't it?
It makes sense, though.
Very interesting, yeah, but it works. It's noticing the pattern. The pattern doesn't always have to be related to even numbers, right?
True.
Okay. All right. How about, let's get a little more complex one going, I hope.
There we go.
5 seconds. Ready.
Be quiet, calculator.
How about,
Automatic power down.
See, I remember playing with the Orion that one year. That's the calculator that's talking right now.
how about 20, 22, 26,
Ah,
32.
Oh, 2 4 6 8.
wow, Tower, I thought you were right on.
These are so easy.
That was really hard to answer.
20, 22, 26, 32. So we have up by 2, up by 4,
Mhm.
up by 6. So the next 3 numbers would be up by 8, up by 10, up by 12. Yeah, pattern within a pattern. All right. Okay, let's try this one.
This is fun playing around with this.
That is. How about 10, 13, 19,
Oh, wow.
28.
10, 13, 19, 28.
10, 13, 19, 28.
Hmm.
Trinity's yelling out 3, 6, 9.
That's what it seems like, yeah.
So 10 to 13 went up by 3.
Yeah.
19 went up by 13 to 19 went up by 6. 19 to 28 went up. So then your prediction is it would be plus 12 plus
14.
15.
14. Oh, 15, yeah.
15 and plus 18. Notice they're all multiples of 3, right?
Yep.
3, 6, 9, 12, 15,
Mhm.
18. So
Yep.
28 plus 12, 40.
Yeah.
40 plus 15, 55. 55 plus 18, 73. Yeah. Okay. What would go up on that? 21. Yep. Okay.
Yep.
All right. So we noticed that the numbers were being added by a multiple of 3, right? Okay. All right. Next one. 10, 17,
Ooh, wow.
31, 52.
Like it in 7, 14, 21. Oh. And then 7, 28.
Multiples of 7.
Yeah.
There you go.
Multiples of 7. Right. 10 to 17 is 7. 17 to 31 is 14. 31 to 52 is 21. So we've got plus 7 plus 14 plus 21. That's 7 times 1, 7 times 2, 7 times 3.
Yep.
So the next one is going to be up by 28, which would be 80. All right.
And 35 is
35. 115. Good.
That's so cool.
And then 42. 157.
Oh, yeah.
Good. It's okay. Good. I like that you're temping mental math. Good. You're right. Multiples of 7.
Miss Edson,
Yes.
do you mind if I go use the bathroom?
I don't mind if you go use the bathroom.
But I do.
Do you?
Oh, it's
Trinity
okay.
minds.
Just don't fall in.
Just
I'm not
don't
gonna
fall in. That's right.
I don't think I've ever fallen into a toilet
Don't
before.
jinx it.
I have. Being a blind girl and living with a bunch of boys.
Oh my.
Don't fall in. All right. Now, while Justin's going to the bathroom, are you ready for the next one? Let's kick it up a notch.
There you go.
Let's bring in the F word.
Yeah.
Fractions. All right.
There you go.
So we have 1/2, or 1/2. 3/2,
Wait, what?
or 3/2,
I got that.
or 5/2, 5/2.
Can you read that?
So simple fraction open, 1/2, simple fraction close. Simple fraction open, 3/2, simple fraction close. Simple fraction open, 5/2, simple fraction close.
Okay.
All right. What's your pattern? What's your next number?
9.
Oops.
What?
1/2, 3/2, 5/2, 7/2. Then
I didn't know we were.
9/2 and 11/2. Does the denominator have a pattern?
Nope.
Nope. Just the numerator. Yeah, just the numerator. And so we change it. Now, let's mix it up a little bit. How about 1/2, 2/3, 3/4? Ah, see, yeah, already. So you can see a pattern with the numerator and a pattern with the denominator. You can figure, and those could be, that was real simple, right? They both went up by 1, but we could do something like 1/2, 2/4, 3/8. 1/2, 2/4, 3/8. The denominator is multiplying by 2, and what's the numerator doing? Going up by 1, right? So the next one would be 4/16. Good, good, nice. So that's an example of, even though it's the F word, we can still be pattern. We can look for the patterns, be problem solvers, and go, well, I'm going to look at the numerator, see what's going on. I'm going to look at the denominator and see what's going on. And I'm just going to treat those two with their pattern to create the next number in my sequence. All right? Okay? Any questions on those?
No.
Nope?
They're fun.
You like them?
I love them.
Like little puzzles, aren't they? Yeah? All right. How about let's see.
Will you give us a riddle?
Oh, you want a riddle?
Yes, the best.
No, I don't know if I have a riddle right now.
9:55 a.m. Status bar item.
What would be, let's see.
Buffer 3 fingers to reveal the control session. Zoom block.
We were thinking about a picture. What if we had a square and a triangle, and a square and a square, and a triangle and a triangle? What would you say would be the next step? Squares, 3 triangles. Yeah, does that make sense, Tabitha? Yeah? What if we had a triangle and a textured circle, and a triangle and a textured circle? We have a triangle and a textured circle. Good. What if we had a triangle and then a triangle with a circle inside of it, and then a triangle with a circle with a triangle inside of the circle? Yes, a circle inside the triangle and a triangle. Yeah, so pictures can have patterns too, can't they? Right? And so it's not just about. Now, what if we had? So here's a tricky one for you. Think about this. What if we had a triangle, a square, a pentagon, triangle, a square, and a pentagon? So what do we know about a pentagon? You know what pentagons are?
There are 5 sides.
Five-sided. All right.
Just putting the triangle on
Yeah, we could. That makes a pentagon, but the triangle is sitting by itself, the square is sitting by itself, the pentagon is sitting by itself. Tabitha correctly said pentagon has 5 sides. So 6 sides, right? How'd you know that, Erica?
because it went
3, 4, 5. A triangle has 3 sides. A square has 4 sides. A pentagon has 5 sides, so we'd have a hexagon. What would be the next one? 7 sided. That's called a septagon.
What's it look like?
Just a 7-sided figure. You just gotta put 7 sides together. What would be after a 7-sided? Octagon. 8-sided. 9-sided. Nonagon.
Oh.
Yeah. 10-sided. Decagon. Decagon. Yeah. That's what 11-sided is.
I remember that.
So that was something where you were thinking about shapes, but the shapes didn't really it was like a triangle and a square and a pentagon. What? Right? And then you went, oh, they have, we're counting the sides, and the sides are going up by. What if we went from a triangle to a hexagon?
Yeah, 9.
3, 6 could be 9, right? It also could be 12. We would need to know one more, wouldn't we? So if I did a triangle, a hexagon, and a nonagon, then you would know the next one would have to be a 12-sided, right? If I went a triangle, a hexagon, a 12-sided, then what would be the next one? 24 sides, right? So you can look for the relationship in the picture. What if I had a circle like a pizza, and it was cut up into 3 slices, then it was cut up into 4 slices, next one was cut up into 6 slices? What would the next pizza be cut up into? 3 slices, 4 slices, 5 slices. Did I say 5?
No.
I'm sorry. 3, 4, 5. The next one would be 6. I'm sorry, I screwed you up there. The wedges, and you would count the number of wedges. So let's say I cut up my pizza into 4 slices, then I cut it up into 8 slices, cut it into 16 slices, 32 slices. Then I'm becoming a really good pizza slicer. Okay, let's try a pizza. So you might have to look for those types of patterns in the actual, like a picture of something. Okay? Is that making sense? All right. Let's take a look at if you were to have some sort of test question about solving. How would you answer it? All right. Find the next 3 terms in the sequence 1, 2, 4, and 7. 1, 4, and 7. Keep the answer to yourself. Pretend like it's a test question. 1, 2, 4, and 7. You have to find the next 3 terms.
Windows M, desk O, offline open book manual, outlook center. Opening outlook.
All right. Everything's riding on this test question. It's a 1-question test. You get it right, you get an A. You get it wrong, you get a F. All right. So 1, 2, 4, 7. I see the right answer on Trinity's. I see the right answer on Erica's. Tabitha, you want to tell us what you got?
I got.
You got it right. All right. Everybody got A's. Woo! And Justin fell in. So we'll give him an F for felling. All right. Okay. What if you were given like a standardized test question? Pictures and standardized test questions, don't they? And you had to look at a pattern and figure out what the next item would be. And you'd have a triangle, a filled-in square, a triangle, a filled-in square, a triangle. So you'd have a triangle, a filled-in square, a textured square, a triangle, a textured square. What would be the next 3 terms? A triangle, a filled-in square, a triangle, and a filled-in square. What would be the next 3 terms? Did I say triangle, filled-in square, triangle, right?
Yeah.
Yeah, sorry. Okay. Yes, that's right, Erica. Yes. Great. What do you got, Tabitha? Yep. You'd have another filled-in square, a triangle, filled-in square. Good. Sometimes standardized test questions, especially, they like to throw pictures at you, and you have to make your way through those pictures. Okay? Or you could ask your parapro to describe them for you. We'll practice looking at tactiles in our book, of course, but I wanted to throw that out to you just so you can practice those. All right. What do you think? What did you learn today?
How to fill in sequences.
How to figure out sequences? Why is it important? What do you think? Why are we learning how to figure out sequences? Problem solving. What are we looking for when we figure out a sequence? Starts with P. Patterns. When we look for patterns, what are we able to do? Like, I do my homework and I get good grades. What am I able to do if I see a pattern?
Predict.
You can determine what comes next. Can you make a statement about it? Yes. If my numbers are going up by 6, then the next number is, right? Okay. If my numbers are going up by multiples of 7, then my next number is, right? If my shapes are going up by numbers of sides, one side at a time, then my next shape is, right? If my shapes are going up by every other triangle and filled in square, then my next one is, right? If then, right? You say what's going on, if blah, 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 then I get to say yada, yada, yada. Judge JJ. If I have a sequence of numbers 1, 3, 5, 7, they are going up by 2s. Then my next numbers are 9, 11, 13. Does that make sense? Okay. You're learning how to observe, problem solve, observe a pattern so that you can make a statement about it with conviction. Now, sometimes the statements aren't true. Like, if I go outside and it's cloudy and blustery, then it will rain.
Not always.
Not always. right?
Most likely, but
Most
not
likely,
always.
but not always. The probability of it raining is high. I would have to clarify my conclusion, right? Okay? But in a sequence of numbers, it's pretty solid. 1, 3, 5, 7. Pretty clear that it's going to be 9, 11, 13, right? It's not going to suddenly be, sunshiny, my bunch of my numbers, right?
Will you tell us what's for lunch?
What's for lunch? Nachos.
Yay!
With
Something
beef.
edible.
Beef, rice, peaches. Beef just ruined it. Yeah, I'm sorry. All right, my watch just buzzed, so it means we got about 4 or 5 minutes. Do you have any questions? Okay.
Can we do this again sometime?
Yes, we're going to review tomorrow, and how we're going to review tomorrow is your assignment for tonight. Listen up. Your assignment for tonight is to create a sequence that the rest of us have to figure out tomorrow. Okay?
Okay.
Create a sequence that the rest of us have to figure out tomorrow. So at the beginning of class, you need to be prepared with your sequence and the answer, so you know if we get it right or wrong, right? Okay. All right. Enjoy the rest of your day. You may leave. I'm going to stop the recording.